Let's say that we have an infinite series S. So it's the sum from n equals 1 to infinity of a sub n. So we could write it out a sub 1 plus a sub 2. And we're just going to go on and on and on for infinity. We're going to go on and on and on forever. So let's say, and I've written it in very general terms, let's say we have a formula for the partial sums of S. So we know that S sub n is equal to 2n to the third over n plus 1 times n plus 2. Now my question to you is, based on what I've just told you, S is this, I've in a very general way written this infinite series, but I have the partial sum. The sum of the first n terms of S is given by this formula right over here. Does this series converge or diverge? Does this thing converge to some finite value, or is it unbounded, and does it diverge? Well, one way to think about this is the idea that our infinite series S is just the limit as n approaches infinity of our partial sums. So what do we mean by that? Well, you could imagine a sequence of partial sums here. So you have S sub 1, S sub 2, S sub 3, and you keep going. So this would be the sum of the first term. This would be the sum of the first two terms. This would be the sum of the first three terms. And just think about, well, what happens to this sequence as you go as n right over here approaches infinity? Because that's what the series is. It's the sum of the first, I guess you could say, the first infinite terms. It's the sum of all. You have an infinite number of terms here. Well, let's think about what this is. The limit as n approaches infinity of S sub n, well, that's going to be the limit as n approaches infinity of this business right over here, 2n to the third power over n plus 1 over n, or times n plus 2. And there's several ways that you could evaluate this. One way is you could just realize, hey, look, in the bottom, this is going to be a second degree a polynomial. And up here, you have a third degree. So the numerator is going to grow faster than the denominator. So this is going to be unbounded. So that will immediately tell you, well, this is going to approach infinity. So the S is going to diverge. But if you want to do it a little bit less hand wavy than that, we can actually do a little bit more algebra. Limit as n approaches infinity, 2n to the third power over, let's multiply this out, n squared plus 3n plus 2. And let's see, we can divide the numerator and the denominator by n squared. So this is going to be the limit as n approaches infinity of, if we divide the numerator by n squared, you're going to have, actually, let's divide the numerator and, let's divide it by, n squared. So if we divide the numerator by n squared, we're going to have 2n. And then the denominator divided by n squared, you're going to have 1 plus 3 over n plus 2 over n squared. And now when you look at it like this, it becomes pretty clear. This thing, as n approaches infinity, this thing is going to go towards infinity. But this thing down here, the denominator, this is going to go towards 0. This is going to go towards 0. So the denominator is going to go towards 1. So this whole thing is, the limit is going to go to infinity. And since the limit of the partial sums goes to infinity, that means that this infinite series is not going to be a finite value. It's just going to diverge. So this character right over here is going to diverge. In order for it to have converged, this limit should have been some finite value. So hopefully that makes sense. Always says, look, infinite series, we had a formula for the partial sum of the first n terms. And then we said, oh, look, the series itself, the infinite series, you could view it as a limit of, as n approaches infinity, of the partial sum S sub n. And we said, hey, that approaches infinity. This thing is diverging.